Okay, good morning everybody. Thank you for being here. Forget about the title, I always do this on purpose, just to intrigue you. My name is Alfonso Muñoz. A quick introduction for those who don't know anything about me. At present, I work in BBVA. I manage the cybersecurity lab, and I'm in all these places. If you want more information, I'm available. Here you have all my data, in case you want anything. As this is a special edition, and I'm sure I'll be sorry for wasting these minutes, I'd like to thank the organization for everything they do. In my case, I started with Jorge in CryptoRed, so for this reason I got to know Roman and other people, and this event that we were going to set up that ended up in all this. So, congratulations for everything we have achieved in these past 10 years. Here are just a few considerations. This is something that when we give a presentation, things happen afterwards, and this is a way to acknowledge the organization. This is the 7th time I'm speaking at Rooted, and the Stelling tool, the first edition. I'd just like to say that thank you that Rooted, many people use this in places where the freedom of expression was censored, so many people were able to communicate freely. Many other things. I met professionals, and I learned about malware perimetral. So we started a community working with professional security, hackers, experts, all sorts of suspicious people. So we tell you that the database was of a dealer, but it wasn't that, so the professionals report these things, and these things are resolved, but other type of people do other businesses. So if you're smart, you can deduce things. I will say no more. And the presentation we set up last year, so beyond the acknowledgements we got, and the fact is that we got people, students got in touch with us, secondary school students, interested in developing hardware projects and privacy terms. So with the Rooted and the influence it has, so well, I've waited 5 minutes already. Anyway, now I'll tell you what my agenda is for this presentation. I like to theorize a lot, so there's a question that I make myself frequently, whether we can simulate the best possible attacker, because the defender is always one step behind the attacker. In theory, this is modeled with a perfect attacker, an attacker who has unlimited resources, unlimited knowledge, and unlimited access. So if we were able to model an attacker with these characteristics, as defenders, we might become the best defenders. So, let's see if this can be done. I will talk about intelligence, artificial intelligence, with my apologies. I'm not going to talk about defensive security. I will talk about offensive security. I want to know what we can find out in machine learning applied to offensive security. So I will give you a brief overview. We will focus on Unicode attacks. We'll see the most conventional types of Unicode attacks, and AI response. After that, I'll give you a few examples, actual examples, of things that were sort of old, but they're not old at all. So when we talk about artificial intelligence, Terminator is the first thing that comes to mind, like he will kill us all, a Terminator. But we just have to take a look at the amount of money that governments are investing in picking the best brains of each country to work for their own defense. And in Spain, these things sort of are a bit slower. As regards machine learning, we could talk a lot, and I will focus on the orange part, which is with typical machines and tools using artificial intelligence. In the green blocks, we have other branches of offensive security, everything related how to defeat artificial intelligence algorithms, or mixed attacks, which is the theft of intelligence models, optimization of machine learning models. There's a lot of work being done in this right now. Here we have a link to a website that works on these things. Also, how to simulate real faces, how to falsify authentication mechanisms of all type, fingerprints, voice, audio, video, etc. So let's see the core of the presentation. Anyone in the room who has a certain seniority and a good salary, well, we are expensive professional for companies. We are expensive, but companies have to use us to apply the best defensive measurements. So it could be reasonable to think AI mechanisms that, even though do not imitate humans 100%, but could respond to about 60–70% of accuracy, could save a lot of cost. So when I think about DARPA, they are years ahead of me. When DARPA has many resources, so they are in the vanguard. I'm sure you know the cyber challenge. In this case, DARPA is interested in artificial intelligence to detect software security failures, to detect this as well as to take advantage of them. So if we go to a more tangible environment, beyond the hype in all this, there aren't many real examples. Setting aside the commercial tools, because they're not to be trusted, and we focus on public tools, we can see the majority are focused on agilizing phasing procedures or improving classic listing tools. I'll go a bit faster. Here you have the links so you can check them out, but these are used for improving SQL queries or XSS. These are some of the most meaningful websites. Did you know that Nmap used logistic regression to identify IPv6? Well, I didn't know that. So don't feel bad if you didn't know about it. Okay. Deep exploit, of all the cases we have, none is sufficiently mature. They're all concept tests. The most significant projects we have analyzed is deep exploit. They used neuronal networks and metasploit. It's a very simple idea. Let's see, we have a senior and junior pen tester. The junior lists a system, it has a web server and starts launching exploits. And with a bit of luck, it works. A senior tester would make a list and with greater knowledge would go to the specifics. This system does something similar. It uses listings with meta-exploit, and it learns. And when it learns that some exploits work better for some lists or numbers, he focuses on it, and so on and so forth. It's not like a human pen tester, but this is one of the most advanced things that we have seen publicly. You can download it and play with it. After the previous presentation by Pablo and Jaime, well, please note that everything related to cracking is moving exponentially using this type of technology. In this case, PassGAN for generating mutation rules, taking dictionaries of keys that have been stolen, for instance. You generate mutation rules, and then they use the typical tools that we use, like hashtag or the like. So this was the introduction. I have captured your interest, I hope. It seems that large organizations, to understand a little about security, like DARPA and others, are analyzing this, and we see what we have on the public side. It's not fully mature, but there seems to be some interest. So I will stay with this procedure in my mind, and I'm working on it. But now we will focus on Unicode encoding attacks. This is old, but for some reason, I wanted to look over it. So it's a redundant question, but what do these problems have in common? The senior ones here will know a few about evasion of HTTP IDS, occultation of malware, more recent problems. Apple finds a bug that causes iPhones to crash with Unicode problem. Here we have a number of headlines of failures, mainly by Apple, for incorrect processing of Unicode chains. Take a look at these things, because later on we will discuss about browsers. I haven't included here any Spanish company, so the only one I will attack here is Rooted. Anyway, that's a joke. Those who are programmers in Java, I mean, I know many people hate Java. I'm sorry, but I like it. What security failure you see in this code? I developed this code. This simulates a server, a payload, a port, which is of course fake, a socket, and I print a screen message. So what is the security problem in this code? Very quickly, because I'm running out of time. No one? Come on, someone has to identify it. The failure, the security failure is right here. I'm not calling the class system in Java. Here we have a package, talks about system. Here the actual change is that this S is not Latin, it's Cyrillic. So I'm using confusables to alter source code. You have to take this into account, because someone can deceive you with this. So, taking this into account, and in case someone doesn't know what Unicode is, a single slide to show it. Unicode is a representation system for exchanging text in multiple languages. The only thing you have to take into account in Unicode is that there is a huge amount of characters. The last version has 137,000 characters, and these are grouped in blocks. This is important if we want to evade protection measures set by browsers. Remember this. Security problems in Unicode and countermeasures. From now on, I will focus on the right side, the homograph attacks. One is of these blocks is related to Unicode encoding attacks, and to develop countermeasures to these attacks, you need a lot of knowledge. This is focused on good application security testing, phasing processes, safe developments, and in-depth security. So I'm not going to get into detail here because this you have to use the software very well. I will focus on this one on the right, the homograph attacks. Many of you know this. This is your URL example with BBVA. That's the typical thing we talk about when we get attacks. URL in Latin, but I put it in Cyrillic instead of Latin. So visually it looks the same, but they're different. So in order to protect itself against these attacks, the industry developed the Unicode standard. So in any web browser, if you introduce this false URL in Cyrillic, someone could try to do a phishing attack on BBVA. Well, the attacker will have a hard time doing it. So, questions that occur to me. The policies used by browsers to protect us against these situations, are they always functional? Do they always work? Sometimes yes, sometimes not. The confusables are critical, those characters that seem similar could be used by an attacker. This is all related to AI. Maybe it could generate all possible characters and simulate the best possible attacker. If you simulate the best attacker, well, I could get in. We could see if this is possible. And then beyond, as we will see later on, apart from doing phishing, you can analyze source code. It could deceive AI model, do covert channel, evasion of intellectual property mechanism, etc., etc. So, the idea of having a visually similar character can be used for many things. Time-wise, I'm doing okay, apparently. What have we done? Here I will try to generate the best dictionary of confusables. For this I will use deep learning. This was a long process. I will summarize it in a couple of slides. So what I tried to do was, with an automatic procedure, find visually similar characters for humans, but without using a human. So we picked up was the entire Latin alphabets, and we compared each character visually with 38,800 Unicode characters. The system was something like this. There's a lot of science behind this, but it looks simple. So we took the visual representation of each letter and compared it with all the Unicodes, with a neural network system. So we got a probability. If you enter an A and a B, this is like, so playing with this percentage, you can get many similarities. So what is the result of all this? the best confusable dictionary existing on this planet. I don't know if you know the EBIT URL tools that are typical tools for phishing or falsifying domains. Well, these tools are quite better than that. If we want to use even better tools, we can use the Unicode standard as reference. Basically, you put a character in, and it shows you visually similar characters. Like this one here is from the Unicode, and here this is not. So, with all this system of deep learning, we developed a dictionary that is better than the conventional dictionary. So we got 50 similar characters for each character, and here we have a quality above 10-15%. This quality percentage is subjective because when you see an A, it is an A or not, depending on each human being, and this is done by machines. So a visual checkup gives an improvement of 10-50%. Here we conclude that you can use deep learning in offensive tools. The summary of this is the dictionary, which is quite ugly, as you can see. It's not very pretty. You can download it. It is accessible for anyone. And you, for example, a letter A, but there are others that are visually more similar and others that are less similar. Some will be more useful for some scenarios and others not. However, it is important to have all the possible combinations because this will allow us to test a number of scenarios. So what do we do with all this? We create the URIDeep tool, URIDeep. You can download it from GitHub, as you can see there. This tool includes many of the current techniques for generating false domains and see if anyone is trying to do a phishing, but it also has other advantages. One is that it uses this dictionary, so if you work in any organization and you put the domain, it will test all the possible domains that an attacker may use for doing phishing. So you can download this and play with it. Other characteristics, now I'll tell you about this. We have this dictionary created, the best dictionary on earth about confusables. So let's see some examples. I will show you 3 cases, one with URL, then intellectual property protection, and the last example, which is close to my heart, is related to the CIA. Later on, I'll give you more details. As I had the best possible dictionary that an attacker can use, I took a look to see what the bad guys are able to do. So I made a list of all the Spanish stock exchange company, the IBEX 35, and a list of all the live SMEs, 25,833 SMEs. So I made the online betting websites separately. And at the world level, 10,000 top domains. These domains you see here in the case of Spain, these are live, active domains. Some are registered by the companies, others are not. So if you are in that list, maybe you should take a look at your policies. Inditex, Bankia. There's this one about Garcia Vaquero, which is cheese manufacturer, which I wouldn't like him to be caught with his defenses down, because I like their cheese. This is a funny example. Analyzing the BBVA, I got this one. This is BBV4, which is a Chinese porn website. It would never go down as phishing, but you can imagine. Well, it is a funny thing. Here we see in the red the live domains, It's not only the domains the attackers could use, because there's a huge amount of domains that could be registered. These are only the live ones. Of the top domains, out of the 10,000, I identified 20,836 URLs that are distributing rubbish. Samsung, this is nice with a sort of triangle. Amazon, Google, so the attackers use these combinations, and with this dictionary we can identify them. Maybe someone wondered that all is well with these URLs, but in the end, if you click on a URL, it'll take you to a browser, and the browser will implement some protection that will expand the URL to increase your protection. Here are two different topics. One is that the browser will expand the URL. Doesn't mean that the URL cannot execute an exploit or JavaScript. So we have to avoid anyone deceiving us to click on a URL beyond the protection of the browser. Then we have the browser protection per se. This is an example of security policy followed by Chrome to decide when it has to expand the website. Here you can spend hours to see if you can think about some scenario that can evade this control. This is well thought out. The majority of cases are covered, but not all. So here I leave you potential characters with which you can create URLs that evade the protection measures of Chrome, Firefox, and other browsers. So there's the phishing I did to the router so that nobody gets angry. So this is, I don't know if you can see it properly, the R is an R with a little dot underneath. So I've cloned the web. So with a URI-deep you can enter the -L option and you get potential domains, -C option as well, and you can check whether they're live or not. So if you want to do an exercise of targeted phishing or whatever, you can evade the security measures, the IDN, the default IDN policies of browsers. So this can be done with all the companies of the IBEX 35 and the SMEs, countermeasures in browsers. In the case of Firefox, they force the application of Unicode. If you force it, it does not execute these IDN policies, so this attack wouldn't work. So if you do about config in Firefox and you force this to Q, it will expand. And in the case of Chrome, you have to install some extension. In this specific case, if someone introduces this RootedCON website, the Unicode would trigger. So you can force this because if you have URLs, they could deceive you. I love this picture. So what happens with all this? We have seen that there could be specific scenarios, just a few, that could evade the EDN browser policies. And apart from that, even though it expands the URL, if you click on it, it could activate exploit JavaScript, whatever. Something good we did in this industry is in-depth security. I want to know before the browser gets to the place, the URL I get through other media, how easy is it to deceive me? Because I don't want it not only to expand, but also to not execute anything. So I took a quick look at a load of apps, email, WhatsApp, Telegram, etc. So we started with emails. Outlook, Yahoo, Gmail, 110, a score of 10 for Outlook and Yahoo. If you put a Unicode, it doesn't allow you to click it, so you had to go to the browser. And if the user, you enter a user with Unicode code, it doesn't allow it. In the case of Protomail, this is the middle of the road. The URLs are clickable, so you have to have experience here at the bottom. If the browser will expand it, if we use the tool, we enter a domain that deceives the domain protection, you can get in. The poorest one in this regard is Gmail. The URL is clickable. That would be improvable. And in the case of users, you can enter a false user with Unicode encoding. So I send an email to Roman, I put CEO@ferrovial.com in copy. It's not the CEO, but the CEO, instead of being in Latin C, I put it in Cyrillic. Right now, Gmail allows you to send these emails. The recipient will receive it, and unless they have some training in security, he won't be able to visually differentiate whether the mail is from the genuine CEO or the bogus CEO. So this is allowed by Gmail. So you report it to them, and they say this is not a security failure. So just be aware that this can be done through Gmail. If we talk about instant messaging, which is where the party is, if we talk about Skype, in the mobile application, web and desktop, they proceed differently. In the desktop version, there is no human way, unless you copy and compare it, to realize whether the domain is true or false. They can deceive you. In this case, Microsoft has managed this quite well. I reported it to them. They admitted it was a security failure, and they corrected it. They published it in the security bulletin, and that was it. Others do a good job. Facebook, Twitter, they do a good job. In the case of LinkedIn, there are some scenarios where they act poorly. If you publish an article, the URL is not properly expanded, so you could be deceived there. In other types of instant messages and social media, Instagram and Twitch, they don't allow it to be clicked, but doesn't expand it either. So they are in the middle of the ground. So if you use a free social media, it's relatively easy to deceive the final user. There are no mechanisms for you to see whether the page is legit or not.
In case of Signal, Telegram, WhatsApp, this is an actual disaster. There is no possible way for you to know whether the URL is legit or not. So in the case of Signal, we have the app and the desktop. There is no visual way for you to tell that this is a false domain. This is in Latin, and this is in Cyrillic. I reported that to Signal, they just ignored it, and the same goes for Telegram. Well, in this case, this was the answer that I got. Well, thank you very much, Alfonso, but another security expert reported it to us 5 days ago. In the case of WhatsApp, I also reported its failure, and they said they did not consider it a security failure. So, well, bear this in mind. Now, if we go to G Suite and Microsoft Office, they are acting rightly, they're doing it well. Even they give you good enough information for you to detect that someone is trying to deceive you. And in OpenOffice, you can be deceived very easily because they act very poorly. Google, so final users and users have difficulties in telling a legit domain from a non-legit one. I reported it, they ignored it. In case of PDF, Acrobat Reader does it quite well, and in case of Foxy Reader, I don't know whether you use it or not. This is the typical reader for PDF files, so Foxit doesn't have security in. I reported it to them. They are serious people. They acknowledge the security failure, and they will be including it in the security bulletin next month. And for those of you who are a bit lazy, this is a summary table. These are the ones that have detected a failure. Skype desktop, well, admitted the problem, is trying to fix it, is fixing it. These other two, Foxit Reddit, did not answer. These other two answered, but they said that they would not implement any security changes, and they said, well, that what I did was just social engineering, that they were not interested in that. Okay, this is a summary table for you to bear in mind. And now, good. I just didn't want you to feel that these confusables, yes, I'm going really fast because I'm finishing. I just didn't want you to have the feeling that this is only good for phishing or to detect false domain. Confusables can be used in any scenario where someone needs to process a text, and if there is a human person around or involved in it, may use it, may find it useful. To finish off, I'd like to share with you two examples. One is about IP, bypassing IP tools, and the other one about creation of cover channels. The first one, please do not get angry at this, please. I know that delivering a speech at RootedCON is good, being a hacker is good, but actually what it would be the coolest of the coolest would be to be the prime minister of the company, of the country. So it is a problem when you plagiarize a PhD and then you are caught. And writing a PhD is lots of hard work. I know it because I wrote a PhD myself. So now let's take a look at the programs that were used to detect plagiarism. We start off on the right with black scum. I reported it to the manufacturers. They also ignored me. That I reported it 5 or 6 months ago, and they have not answered yet. So I just entered a text from the Quixote. So anyone could identify that this is a text from Quixote. So when you enter the original text, Plagiarism tells you that you have copied it with 99% likeliness. What happens if you replace one character? Instead of Latin A, you just type in Cyrillic A. So the probability goes down to 0%. So you fully deceive it. I don't know whether some of you who are following security master's course, please be careful with the tools. So in case of Turnitin, which is a software widely used at many universities, we could say that Turnitin performs a bit better. So to be honest, I devoted half an hour to these tests, so I didn't do a full auditing. But this text of Quixote, the 100% went down to 18%. So in this case, I did not replace one character only, but I needed to replace more than one character. Well, because this is just because of the algorithm that Turnitin is using. Even if it may sound a bit old to you, many software is not good at validation. And now, another example would be creation of cover channels. We have published the tool, which shows on the screen. It is a beta version. This tool offers several options. It allows you to create cover channels by using confusables, but it also allows you to do other things. If you were to download it today, the features that perform are these ones here. So the previous tools were made in Python. This is developed in Java. You just enter text of your choice, then the message that you want to hide or to cover, and then this is the result. The result uses Confusable as well as an ID system to hide or cover the information. You see that with the text, but you could use that in social media. This is an example from Twitter. Here we are using Confusables to code information. And here we have some 40 bits covered. Good things that we can get from this tool in the future. In the future, we'll work with text, PDF, Word, HTML. We will be adding a feature, this one here. Over time, people have demanded me to create Stego libraries that are transparent. So the idea of using any tool, plug it into a library so that it would do Stego in the background. So you configure it and everything that goes through it, all the techniques will help code all the techniques. We will be entering other techniques that are best known, so the use of tagging for creating uncovered channels. So this is an example where we use non-printable tags in Unicode to create covered channels. You can do that in Twitter. This is what the user can see. However, at the end of the day, there are some codes of Unicode that are not visible, so therefore you can cover quite some information. So actually, this is the amount of data that have been covered. So to finish, I tried to analyze the developments and advancement in offensive security with artificial intelligence. Actually, there is more hype than actual work or results, yet we are seeing some examples, hopeful examples, about its future practicality. It is sad to see how some Unicode coding issues are still impacting us today. So this continues to be there, and because security is never fully or validated enough. So this is a full dictionary of confusables. Use it to test security in any type of application. I show you these examples, but I'm sure there are very many others out there. We also would like to put at your disposal the URI-deep tool. You will see all the possible combinations that an attacker may use to make phishing to you. You can also use them to see which are the domains that are live and those that are not live. And in case you do pen testing or red team exercises, this will help you generate URLs offering security, Firefox, Chrome, etc. And think about this, and bear it in mind, and consider the other scenarios where you could use it other than URLs. I would like to thank Roma because I've been sending him phishing for 2 months now. I also would like to thank Miguel for giving me a hand with the tools, and Jose and Samu, who are the people who know the most about artificial intelligence. And well, this is all from me. Thank you very much for your time and attention. I've gone a bit too fast, so there's time for questions. So thank you very much. Great for the library. So please pass on the code to me, and then we will compile them in DLL, and then we will upload it to Emil. For your questions, please use the microphones provided. There is a question over there.
Hola, Alfonso.
Hello, Alfonso.
Primero,
Impressive presentation. As impressive as always. I have two questions now. So, creating malicious URLs. In doing so, have you checked whether people read the full URL or just the beginning of the URL has more weight, so to speak? Because perhaps when it comes to creating the tool, you prefer to include the characters at the end of the URL because people may not read the full URL. No, I didn't do that, but actually what the tool does, it tests all the possible combination. So for instance, if you type in RootedCON, it starts off with the R, and then all the possible characters for R, it generates a domain, then it goes to O, then generates all the domains. So the logic that you are sharing with me is not followed. Does it do scotting? No, it doesn't do any scotting. Actually, it does all the possible combinations for scan, long domain, for instance, of an IBEX company. You may end up with 2,000 or 3,000 different combinations. But yet, what you are saying could be very interesting. Thinking about in terms of the attacker. Another question now. So imagine that I am the attacker and I want to make phishing to Apple. The similarity between characters. Have you tried different sources? For instance, Unicode, most used font in Apple? No, I didn't cover that. So that could be useful, what you're saying. So I showed you this example with the Latin character, but you could also try it out with other languages. We did some testing with Chinese language. Imagine that you want to make phishing to the Chinese. Deep learning also allows you to use different combinations. And what I showed you was for the level of characters, but for this type of attacks, you can combine more than one character. You may go and say, I join N with, I don't know, with another symbol, and then you get like a different combination. But what I did was more generic, but what you're saying specifically could make it very interesting. Any other questions in the room? Well, I have one myself. Please go back to the URL of LinkedIn. Instead of targeting the domain, have you thought about targeting the HTTP semicolon dash dash? Well, that will be a domain when you click on it. When you register the domain, you go through all the regulations. My experience is as follows with Udari and other providers, and when I shared that with other people that did similar things, for instance, at INCIBE, when you register your URL, if you are not in these strange situations that I shared with you, most of the register ask you to register it in Unicode formats, and that you cannot change it. In the dictionary, have false semicolons for dashes, but no, I couldn't do it. I tested it and I couldn't get through. Okay, well, we could test it ourselves later on. Very interesting. Alfonso? Is there a last question? Well, no more questions. Oh, yes, there is one question. Oh, a brave person has a question. So when you train the neural network, I take that you trained it with a specific number of sources. Oh, thank you very much for your question. Fortunately, I have time to answer it in full. So you were all the time talking about a generic attack, but I understand that it is for a set of sources that represent those characters with similar glyphos. Well, the source doesn't really matter. It's not important. I'll tell you more about it. Basically, one of the interesting conclusions of this part, and as I say, I discussed it internally with the people that I mentioned at the end of my presentation. So knowledge about tools and library has advanced so much that any security researcher or professional can easily use those libraries and tools in his system. This system, well, we did not invent any specific network. We invented a technique which is known as transfer learning in artificial intelligence. Transfer learning is very easy to explain. Imagine that there are a number of algorithms that allow you to identify tables, so to speak. You may take that algorithm and specialize it so that for it to identify a leg, table leg for you. So you specialize knowledge. What did we do here? We got an existing model, we made it specific to our environment, and this neural network tells you how much two images look alike. We just don't go into the source, we just don't go into anything. So this neural network tells you the level of similarity between two images. Yes, but images are fonts. I have fonts where I tested that, where the O and the 0 are identical, and whereas other fonts, the O and the 0 do not look alike at all. Yes, as I said before, in Unicode, all the possible combination of characters are reflected, and we swipe here, we scan all that. Yes, but in RootedCON, a long time ago, there was a presentation precisely about that, about replacing zeros and O's that are similar in some fonts. Yes, we can discuss it later on, but I don't know whether I'm answering now. But here, basically, you are testing all the possible combination, whereas in the standard, in the Unicode blocks, in the specific case of this tool, I've used these Latin characters. Well, we can discuss that later on, but imagine a different example. So the idea would be just a similar thing. You take this, you do the correlation, you extract the similarities, and that's it. So thank you very much. You've gone very fast through the source code. Did you test the typical editors where you enter source code? No, I didn't test that. Is that Notepad++? Yes, it is. And is that the way you view it? Yes, that's exactly it. So I can upload a report to GitHub with completely fully false libraries, looking like if I were doing an import system. I'm not going to download your code. Yeah, you may upload that, but I don't know whether you will visually see it in GitHub. No, I'm not saying in GitHub, but if this works in Notepad++, look, I just didn't want to correct it, but if we go back to the dictionary, you see this in red, isn't it? Shows up in red. This is what happens when it does not identify character. These are the characters that Notepad++ does not identify. Anything which is not in red, it is identified by Notepad. So I didn't test what you are telling me, but I could do it. Well, you have a next thing to do now. And now when it comes to, well, now for those of you who edit code, when you do code editing, well, surely you will notice that you see the package, you would enter the package, you would analyze it, you will research it, you will see that there is something wrong. This is an example of how you can use this tool in other scenarios. And what about malware? I'm thinking about very many different vectors. All right. Thank you very much. Is there a last question? Yes, there is one there. In terms of defense, imagine that with Juridip you have a list of all the domains, for instance, for rooted, and then you go and detect that you have to register a malicious domain. So the domain providers can get, if they get a notification, if you report that to domain registrators, would they do anything to fix it? Well, the good thing about this tool is that it will show you all the options. So if you download the tool later on, you will see that the tool goes in a readable format, and then it goes into Unicode format. Most of the registers allow you to register it in Unicode format. When I executed this, which was at the end of February, So nowadays this is not used massively to launch any attacks, but now when you have this tool, you can defend yourself because you have all the tools that you need. Problem is that if you have the Unicode domain, someone may register it. If that happens, you would report it. And then additionally, if you register it yourself, which is easy to register Unicode, you may use some of the scenarios that I used before, Signal, Telegram, and others, so that someone will click on it thinking that it is legit, and then it would be your domain that you registered in Unicode. I feel that you can report that to the provider, and then the provider or the register will take action. Here there are very many security services providers, and there are many in this room providing services to me. Specifically, they are sitting in row 4. So you get the tool, and you are cutting in the browser proxy all the domains of my company. Yes, he got really angry the other day because I sent in a list of domains in Ferrovial. There were like nearly 8,000. So thank you very much, Alfonso, and thank you, everyone.